Hey everyone, today we're going to be talking about lesson 7.2, which is the natural base E. And I want to let you know right up front that E is a special symbol, kind of like pi, that represents an irrational number. And that irrational number is approximately 2.71828, and it keeps going on. Just like pi never ends, neither does E. Let me explain real quick where E comes from. So it kind of comes from our compound interest equation that we used last time. Let's look at kind of the middle part. So ignoring the A on the front, if we just took that B value, 1 plus, technically it's usually an R, but I'm going to explain to you in a minute why I'm just going to put 1 over N, and then usually it's to the N times T power. But again, I'm going to explain to you why I'm not putting a T there. So what I want to do is look at this expression as N is approaching positive infinity. So if N is getting bigger and bigger and bigger and bigger, it honestly doesn't matter if this is a 1 or some other number other than 1. The bigger and bigger that N gets, the smaller this number gets. Kind of the same thing here. If N keeps getting bigger and bigger and is approaching infinity, it honestly doesn't matter what time T that we multiply by. It's still going to be, the N is going to overpower it as N gets closer to infinity. And so as N approaches infinity, this ends up approaching our E value of 2.71828. To prove this to yourself, take your calculator and put in 1 plus 1 divided by, I don't know, 1,000,000, and then raise it to the 1,000,000 power. So 1,000,000 is a 1 followed by 6 zeros, and do that in each place, and you're going to get something very close to this number. If you kept going bigger and bigger, you would continue to get more digits of this number. So that's where E comes from. So it's used in compound interest when we are basically compounding continuously. So instead of an interval like quarterly, where we would have an N value of 4, or even daily, where we have 365, our interval is going to be so close in time that it essentially is continuously compounded. On your calculator, just like you're able to get pi entered on your calculator, you can get E entered on your calculator. And in order to do that, you push the second key, the blue key, and a division symbol. In Desmos, you just simply type a lowercase e. So if you're using Desmos at home, the graphing or the scientific calculator, just type in E, and Desmos recognizes that as Euler's number. Let's talk about how to deal with E in expressions. And E can have an exponent on it, similar to a variable. So because it can have exponents, similar to variables can, we use the same types of rules that we had for exponents on variables. In other words, if we are multiplying two things that have E as a base raised to an exponent together, our exponents are going to add. So E to the third times E to the sixth would be E to the ninth. 3 plus 6. If we're dividing, then our exponents will subtract, just like if E had been any other variable like an X. We'll have 16 over 4 is 4. E to the 5 divided by E to the fourth. Well, 5 minus 4 is 1, so that just gives me a 4E. We can have negative exponents on E. And remember that when you have a power raised to a power, your exponents will multiply. So 3 to the second power will be a 9. Our coefficients do get powers taken. And E will be to the negative 8x power, negative 4x times 2. However, remember that we can't leave a negative exponent in a simplified expression. We need to fix it. So this is going to become 9 divided by e to the positive 8x power. Remember that negative exponent means take the reciprocal of the base, but make the exponent positive. Finally, if we are taking a root, we again kind of treat it like an exponent on a variable, and we will simply divide the index into the exponent. First, we'll deal with our coefficient. The fourth root of 16 is 2, because 2 times 2 times 2 times 2 gives me 16. And now we need to say how many e's we can take out, just like we would say how many x's. Well, this time 4 will divide into 24x 6x times, and that goes evenly. We don't have any left over, so we'll have 2e to the 6x.